I am Kevin Galligan. I'm a partner at a company called TouchLab. I've been coding for a while, been doing Android since before they had a phone, yada yada. TouchLab is a mostly mobile shop, been around for almost a decade. It was mostly Android. Now we do a lot of other things plus hardware, and we're deeply invested in Kotlin Multiplatform, which has turned into my personal obsession. And luckily we have some interesting, very supportive partners out in the wild who've helped us out, and we're in Toronto, so definitely have to mention them. Hi, everybody. Okay, you should thank them if you start using multi-platform stuff, because they're really helping us work on multi-platform stuff too. This talk was going to be given here, and it's sort of like get the feedback, and then I give it at Kotlin Conf in front of like the Kotlin native engineers. So we're gonna refine everything, I'm gonna be super smooth, and everything's gonna be great. And then this happened, which is a pull request for multi-threaded coroutines, like literally some few days ago, which kind of upends a lot of what I was going to say and a lot of the status of the situation. So this talk is going to be interesting. It is about as non-fluxed as I could make it, but there's definitely towards the end loosey-goosey, just letting you know. Also, if you have never done anything, has anybody here done any Kotlin multi-platform? Woo, raise show of hands. All right, well, it's gonna be interesting, hopefully. We'll see how it goes. It gets a bit in the weeds. So, intro. I'm also merging my design team's new theme, which is sort of merged. I talk a lot about this, and I feel like as native mobile developers, there is native mobile and then everything else, which is bucketed as cross-platform. So I tried PhoneGap in 2013, and it was bad. Cross-platform doesn't work for me kind of thinking. And it's important to define these things in very precise terms to talk about the different pros and cons, right? So this is sort of like the slide I put out in my intro talks about what differentiates Kotlin multi-platform from some of the other options that are out in the wild, which I will not read the whole slide, but I'm mostly going to talk about the modern aspect of it. And specifically, this is like the Kotlin multi-platform deployment space in a nutshell, and we're going to talk about just the native side of it today. And when I talk about modern, I'm really not talking about like there's nullability syntax. I'm talking about the platform as a whole. So if you watch Kotlin Comp's keynote from last year, Andre talks about this thing called scalar concurrency. And in general, they're talking about how the language and the runtime are evolving to adopt best practices seen in other languages and runtimes. So scalar concurrency is one of the topics, and it's specifically getting started in native is the first place that they're experimenting with it. So concurrency is hard, right? And I could give a talk about why concurrency is hard, but that would take a lot of time. It would be several talks. It would be basically my career focus and write books and all that kind of stuff. And you still need years of experience to understand why it's hard, I think, at an intuitive level, so I won't. But I will say I had this sort of thought, like, fear of concurrency declines as you get more experience up until about mid-level of engineer, and then you get to experience really bad things and see other things that people do and you don't trust them anymore. So when you get to be a gray hair, as they call it, you're super afraid of concurrency, mostly what other people do. So 2008, I was making a trading system at a startup, and we used JBoss to stream this like serialized stuff from Java into JavaScript, which was awesome for 2008. It's probably garbage at this point. The JavaScript would inflate the data on the client, and life was really cool. And we had live phone brokers in the same room as the developers. And once the platform got popular, occasionally the screen would just essentially implode. And what they had was a check to make sure that the time the local machine thought it was the same that the time the server thought it was. And occasionally it would think it was not 30 seconds off, but several decades, things like that, and it would explode. And then there are phone brokers who are not necessarily stable people to begin with in the same room losing a bunch of money as us, and they would yell at us. And it turned out somebody at JBoss in the streaming code was using a single simple date format to serialize dates that went to the client, and that was one of my top 3 horror stories of figuring that out. So concurrency is hard, especially when it's something that someone else does. That's the summary of that story. So Kotlin Native's model is controversial. There is, I would say, to put it mildly, some disagreement out in the wild. It is different than what you're used to if you're a JVM developer, and the community is kind of split down the middle on this. Some like it, some super, super hate it, and be prepared for some chit-chats. I would point out to people that the JVM model is also controversial depending on your background. Unrestricted access to shared state between threads is not necessarily a good idea if you are using Rust or Go or whatever else. Certainly JavaScript is something that doesn't allow that. So even Swift is like not formalized how they're going to handle concurrency, and there's discussions going on about that. So it is not necessarily a settled topic. It is in the minds of JVM developers, but not everyone else per se. And out in the wild, some people don't like threads and that kind of stuff, right? Just pointing that out. So this talk will cover how the model works, how to have concurrent code in native and multi-platform-ish. That's the part that multithreaded coroutines kind of threw into the trash. So we'll see. And where things are and where they may be going, also a little bit thrown in the trash because of that. But we'll cover it as well as we can. And then libraries and best practices, which are fully thrown into the trash. So let's see, I had a note, yada, yada, yada. Okay, anyway, this will not cover me selling you on this model because that is a contentious topic, and I'm not going to do that to people who are very opposed to it. And me complaining about the model either. I'm just going to talk about kind of what it is and how to live with it. And I'm certainly not going to debate various perspectives in the industry, like suggestions of changing the entire Kotlin language. I don't think that's going to work out. So I will say the one thing I do know is if you're going to try Kotlin Native, you absolutely need to understand that you can't yada yada your way through it and figure it out. It is not that complicated, but if you don't know what's happening, it will hurt you and it won't work. Unless, of course, we get relaxed mode and then none of this matters, which is the other thing I'll talk about, but we'll get to that later. It is important to relax. It is not a scary topic. Things will work out. People are implementing this in production. That is increasing. Libraries are coming out to make this easier to manage. It's just you need to understand the rules. So, Kotlin Native's rules with our little animated spaceship. There's one rule, which is mutable state is visible to one thread at one time. That means it's thread confined. Thread confinement is why you cannot write to the UI from a background thread. That is enforced by, presumably this is an Android crowd, considering where we're at. If you try to change the UI from a background thread, you'll get an error. They are intentionally managing that. Kotlin Native is formalizing that concept for mutable state. And rule number 2 is immutable state can be handed to many threads, because if you don't have any changes, you don't have any concurrency issues, right? And if you understand that, like, great, that's all you need to take away from the talk. See you later. You have to internalize those rules. Obviously, there's a lot more to it, and certainly techniques are going to be different, but that's kind of what the takeaway is. Mutable equals 1, immutable many, and it's important to start thinking of your architecture in that way and seeing things differently. I've been doing this for going on almost 2 years, and when I see something like this, I cringe. Globally mutable state, just hanging out there. You cannot do that in Kotlin Native. It will not let you do that. And that is bananas if you think about it, and you don't need it. But I don't know, maybe you do. Anyway, I don't know. Sometimes I'm wrong. What can I tell you? So you don't manage concurrent state. Like in that previous example, you might annotate that volatile, right? Notice that Kotlin doesn't have volatile as a keyword. It's an annotation, possibly because they were having different thoughts when they were designing it. Who knows? There are atomics, though. We'll get into that. You can use atomics. And honestly, when you get deep into this, are you going to manage concurrency directly? Yeah, it's going to happen occasionally. But the point is to like not do it, and certainly not do it by default. The JVM trusts you. Native does not. Should the JVM trust you? Maybe. Should the JVM trust like the junior developer who joined your team like 5 years after that piece of code was written? I don't know. So that's what they're trying to do. Whether or not it works out again is an open question. We'll see how it goes. Runtime verification, and that is the important difference between what Kotlin Native is trying to do and what the JVM does not, which is it is trying to verify at runtime that what you're doing is not a bad idea. So that's why they have these rules. You will definitely have to do things differently. I argue that you're not really losing anything. This is, again, fighting sort of the initial rejection of this set of rules when people first get exposed to it. There's often like, I'm losing the ability to do things, and I don't like that, and then often follows on with, I'm going to try to get around all the rules. Okay, you can kind of do that too, but you have to like be very careful, and you should probably not do that your first time out of the gate, which is what I did, which is what a lot of people do, and then you get bad things that happen. So we're going to do some code after some diagrams first. We're going to talk about the worker, which is Kotlin Native's concurrency queue. It is one of the core primitives in concurrency in Kotlin Native. You might use this directly in your code, but more likely you will use a library that uses this underneath it. But it is very useful to play around with. You may occasionally have to touch it, and there are a lot of concepts in concurrency in Kotlin Native that this will illuminate. It is similar to handler message queue or just on the JVM and executor service. I had a note to make these diagrams better, but here they are. So hopefully this is good enough for today. So the worker has a job queue, and the worker has a thread, and it's one thread per worker. And Kotlin Native team says that might change, but I wouldn't, for today, just assume, right? So the thread like pulls that queue to do work. It's pretty straightforward. Your thread, often the main thread, will call to the worker and say, I want to execute something. That call takes a parameter and a work lambda, and we'll talk about that in a bit. And worker like looks at that and says, is this legal to do? And if it is, it gives it to the queue, and then the worker thread does your thing, and that's essentially how that works. The details of that look like this. So somewhere in your code, you're going to start a worker, which again starts a thread in the background, so hold on to it. Don't start a worker every time you do work. Then there's this execute method, and there's transfer mode. There's a thing that happens, which is the parameter in the second thing, and then there's what you're going to do in the job, and that presents this to the console. Pretty straightforward. So what are the parts of this thing? This is the signature for execute, and there's a transfer mode thing. Transfer mode can be safe or unsafe. I will make this very simple. Never use unsafe. That's it. I don't know why they don't default that parameter. I don't know why they don't make it harder to call. If you can't explain exactly when you'd want to use unsafe, absolutely don't use it. Then there is this job, which is also straightforward. That's the thing you're going to do. That's your work, right? And it takes the param and it returns something. Both can be unit and omitted if you don't want to do any of those parameters or return anything. And then back here, that's this thing, right? The work. And of course, if you're kind of new to Kotlin, you can put, if there's a lambda at the end of the signature, you can just have a trailing block, right? So returns a future, which does things in the future. I think you should be kind of used to future. So technically, in a command line, we want to do this so we get the result, and we wait for it rather than just exit the process. And then finally, there's producer. Producer is the one that is a lot more interesting. Producer takes nothing, and it returns a generic type, which can be whatever you want, and that is the parameter that it gets sent to the worker job. It's a function and not just a value, and the reason is Kotlin Native is going to try to separate that thing from the rest of the universe so it can pass it to another thread, which again is the, like, you can only have mutable state visible by one thread at a time. That assumes it's mutable. We'll get to that in a second. If it can't, it will throw an exception, and you can't do that. Simply having a parameter would guarantee that the mutable state would not be invisible to the rest of the universe. We'll talk about that in a second. So again, we're back to here. This is the producer, and it just says hello dog. It is doing this, which is pretty simple and actually a little bit too simple for what we want to talk about. We're going to have a data class, and the data class gets returned from the producer, and that looks like this, right? The reason that we made that is because Kotlin Native treats strings and simple types like differently. So to skip ahead, they're frozen by default. That's why we did this. So blah, blah, blah. We return some data, and then this will run fine, and it will just print out some data on the command line. If we do this, which is make a local variable, and we want to pass that into the producer, like this, just to highlight that, that will absolutely fail with a thing called illegal transfer state. And what that is saying is you're not allowed to pass mutable state between threads if it's not completely abandoned by the calling thread. It's going to be seen by two threads, right? So that's essentially what it's trying to do. It's trying to figure out if you can. You still have a reference here inside your method, so it's going to fail, and that's why it fails, which is one of the reasons why I rarely try to pass mutable state between threads, because it is like such a pain, and usually if you're passing state around, it should be immutable anyway if you're following best practices. So it's rare, if ever, that we do that. So what refs? What am I talking about with refs? So Kotlin Native is reference counted, which is similar to what happens in iOS if you've ever done anything in that world. So here is a completely not UML looking diagram of the data of some data. Internally, there's a thing called the container header that has a ref count. So hidden from you in C++ is another piece of state that's counting how many references exist out in the wild. And when that gets to 0, your state will be reclaimed, or technically scheduled to be reclaimed. When you're trying to move that between threads, it has to be exactly one specific number. And if it's not, it will get an exception. So that's what's going on. And it's important-ish to understand that once you get into Kotlin Native, more around memory management and what's going on under the hood. But that's what's going on under the hood. So that ref still exists until the end. It's still not 0, so that will fail, yada, yada. This is a little more complex example where you're trying to like pass in this class, but of course this is also mutable state, and that's going to work in not the same way. Yeah, that probably wasn't super clear. I was going to pull those slides, but I forgot. So never mind. Back to our sample with some data. I said mutable state or an immutable state can be passed, right? But this is a data class with 2 vals. That's clearly immutable. So what's the problem? And the problem is that's not what we mean by immutable state. It is immutable, but verifying that this is immutable at runtime would probably be cost prohibitive if you're doing it in many places. You need to walk the graph. It's just not explicit. And if this was the only way to make immutable state, then it would be kind of like, I guess, restrictive to what you want to do with your state, or at least that is, I assume, what the JetBrains folks thought. So they have this thing called freeze, which is a runtime immutability designation. When I first saw it, I was like, wow, this is really this interesting thing that nobody else does, and it turns out there are other languages that do this. My wife is learning Ruby currently, so I get to experience that. And apparently Ruby has a freeze thing too, so it's not entirely foreign to the rest of the world. Freeze is on any type of object in native. It's only defined in native, which can be problematic. And you call it, and then it gets frozen. When you call freeze freezes everything on the thing you call it and everything that is reachable by that thing. And if anything is not freezable, it will fail. So it just kind of does this. See, on some animations. You cannot unfreeze. Once you freeze, it is frozen forever, but then you can share it between many threads. So that is what freeze is. Freeze has a cost. Be careful. If you have a huge object graph, it's not going to be free. So now to get that work, we can just essentially do this when we're passing into the producer, and then that'll run no problem. So that's what freeze does for you. You can do whatever you want. So confusing sidebar, if you're already confused, earmuffs for a few slides. We're back here, and again, we can freeze it and live in multiple threads, right? And we have that ref count, which is hidden. It's also just state. And in strict mode, which is the default mode for Kotlin Native, the reason you shouldn't try to get too smart around getting around the runtime's rules is that ref count is only atomic with frozen or shared state. It is not atomic with mutable state, right? So you're going to trigger seg faults and do like really horrible stuff if you try to do unsafe, which is why you don't do unsafe, because unsafe will let you do that. And it will probably work the first time, and then it won't work other times, and that's what a race condition is. So don't do that. Confusing sidebar over. Okay, we are back to what we were doing. And yes, that works. Freezing some data lets the method execute. Freeze method returns, the freeze method itself returns a reference to itself, so that's why that's passing in there, obviously. As soon as you call freeze, the local variable in that method is also frozen, so if you try to edit it after the call to execute, it will fail. So what about if we just did this? Well, then you get some other funky things with worker. The compiler complains that you're trying to capture state from outside of the worker, which it won't let you do. Technically, that should work because you've frozen the thing and it should run. And you could probably turn on unsafe mode there and it won't crash, but I wouldn't advise it. What we kind of all do is make a library around this to avoid this kind of garbage in our code. So we're going to make a background processing library right here and now, which takes a block, which takes nothing and returns nothing, and we'll run it. So if we try to do this, we will get the same thing. Like you cannot pass an unbound thing into a worker. And if we try to do this, it's also upset. It will not let us do it. And then if we do this, It's not frozen, so we get the illegal transfer state. So ultimately, we do this, just like with the other state. Freeze the thing and then run it directly inside the block. So say goodbye to your friend worker. That's all we're going to talk about worker in this talk. Now, we've got background. This is a lot easier to digest visually, I would say. We can pass data into it. We can pass a job into it. It will all work. However, what happens when you do this is you get that block frozen, like we just talked about. And when you get that block frozen, it will also do this. And you won't know that it's doing that automatically, which is why you have to understand what's going on with Kotlin Native State, right? That's not a big deal. Local state's frozen. It was immutable anyway. Probably not going to affect your life too much. However, if you were making an app that had a variable called count and you would click a button and it would count for some reason, who knows why, but maybe that's what you want to do. This is what's backing that state. If you decide you want to do this, here is what's going to happen. When you call that, it will freeze, and it'll freeze count, which freezes that count. But even worse than that, it freezes the entire thing. So now your model is all frozen. And when you try to do something on that, you're going to get immediate feedback. In this case, you will get InvalidMutabilityException. And this I will introduce you to as your new best friend, because you will see this a lot. What that is saying is you're trying to change something that is frozen. And it's very simple. Don't do that because you can't. Functions have state. You have to be very careful with what you capture. There's some slides I will present, I think, at some point where maybe you want to pass that count into something. If you just pass it directly into a lambda, you'll capture it. You really want to make a method that you pass that as an argument, and then it will only freeze the local arg in that method. Things like that. You just have to be aware of it. It's not that bad, trust me. So global state. This is some special rules around global state in Kotlin. So in Kotlin, unlike Java, you can have a value that exists out in the wild, free from other encumbrances. And global var val are available to the main thread only, but they are mutable. So if you're only in the main thread, you can just use this like normal state, normal mutable state. If you try to get at it from a background thread of any type, it will throw an exception. Objects are globally available to all threads. That, of course, means they are frozen out of the box. So this thing will not be changeable. Again, it's okay because it's not changeable anyway, but I'm sure there's a lot of people that use objects for caches and other things. You have to be aware that that's not going to work, at least not in that form. You can do thread local on either of these, and that will make one copy available to any thread that goes to grab it, which has obvious implications, but they are mutable. And then you can also make the global thing shared immutable, which means it is frozen but shared to all threads. If you put that on the object, you'll get an exception because it is that by default. So just to turn that around. Debugging issues. So living with the new model. And again, your best friend, your new best friend, invalidability, state change. You will see this a lot, so you have to get used to debugging it, right? There's an ongoing criticism here. I said I wasn't going to talk about the community's thoughts on this new model, but here we go. I get this a lot because we're talking to a lot of companies that are looking at this and evaluating it, especially from the iOS side, or somebody looking for a reason not to use it. It's like, well, I hate the new model because it doesn't tell me anything till runtime. It should tell me at compile time. My argument against that is twofold. Number one, there's a bunch of other stuff that fails that you only find out at runtime. And number two, it will always tell you when you run it at runtime, as opposed to a race condition, which will only tell you occasionally, usually in production. So I don't think it's that bad. Just keep it in mind, right? Cool. If you want to figure out why something is frozen, and sometimes with a large object graph, you won't know why something got frozen. You can put this into this thing called ensure never frozen, and at the moment it tries to freeze, it will throw an exception so you see where it's coming from. Does that feel a little hacky? Perhaps. But it works, and we actually use it on some base model classes in the droidconTO app just to ensure that we don't get frozen when we don't want to. So rethinking architecture, and a lot of this is around minimizing mutability or isolating it in a way that is not crazy, right? And it is funny now that I look at this through a different lens. Oh, whoops. You really think about things differently. It is not radically different than what you're doing now, but you have to be very clear about what is and is not changeable and globally accessible and how you're doing it. So, atomics, mutating frozen state. Inside of a frozen object, you can have an atomic value, and that can be itself mutated. There are atomics for simple values and atomics for reference for objects. So in the case of our counter model, which was failing because we froze it, we're going to make an atomic int. And everything's frozen because that's what happens when you make the background call, but the atomic int can still be modified. So that works. Do you want to use atomic ints everywhere? I don't know, depends what you're doing, but that will absolutely function without any problems. Atomic reference is sort of similar, except it's for objects, and you can put objects in there. They need to be frozen, but they can be modified inside of a frozen thing, right? So here's the initializer, here's a change to that. This is all frozen, that works great, except out of the box, you need to physically call freeze on there. Sorry about the slide wrap. Didn't get time to fix that. But if you don't call freeze, you'll get an exception. JetBrains libraries are explicit. You need to freeze things before you pass them in where they need to be frozen. External libraries, including the ones that we've written, are a little more like they just freeze for you, so you get that clutter out of your code, but you do need to be aware that they're happening. So, droidcon app, we use this thing called frozen delegate. Don't pay too much attention to the syntax, but essentially it's wrapping atomic reference in a bunch of things so you can assign it very easily, and we use it here with a frozen delegate, and then you just get things like this. So you can just treat it sort of like normal state. Just be aware when you're assigning things, they will be frozen automatically, but it is a little syntactically easier to manage. Don't use too many atomics. If you have cyclical data, which will be hard to know just looking at it unless it's very simple, it's possible you'll have memory leaks if you just let them die out. So JetBrains suggests using for long running forever objects, server objects, atomics are fine, outside of performance concerns. For things that are changing a lot and going away, atomics are problematic if you don't clear them out manually, just something to be aware of. There is a thing called detached object graph. This allows you to do that state transfer outside of the worker context specifically. You'll see this much less often. Maybe not when you first start, because I think everyone goes through that phase where they feel like they need all their state to be mutable for some reason. But this allows you to remove state from the universe and then reinflate it in another thread, right? We actually, here's the interface, right? The constructor has a transfer mode just like worker for the same reasons. Defaults to safe, which is actually what worker should be doing, but whatever. And it has a producer for exactly the same reasons. It is syntactically very difficult to take the state that you're working with in a method and remove it from the universe because you're still referring it to the method, which is why we kind of never use it in production. There is nothing that we do in production right now that uses this. However, don't say I never showed you anything. You could do something where you return state from a call that is coming from another thread. So our friend background, right? That worked, if we go back to the thumbs up from before. If we add detached object graph to this, we can return the thing and have it removed from all space and time. So back in our foreground process, we take the result, attach it, and now we have this sum data object, and it is not frozen. That will work. Did you get anything from that? Not really. So we don't do it very much. That isn't to say that you won't if you're doing a complex app. Who knows what you're going to get into. Thread confined state. And this is just some sort of general tips and pointers. We in droidcon app, which is the sample we're going to link to, do a lot of stuff where we want to run something in the background and we want it to come back to the foreground, but we don't want to freeze the foreground state that we're in, which is very difficult because you want to capture state and do something with the foreground when it comes back. And that is with callbacks. Also, when we have a suspend function in the main thread, it has to do the same thing. And essentially what we do is we have this background thing that's definitely going to be frozen, but the background thing is definitely frozen. The foreground thing we do not want to be frozen, and it's pretty straightforward. We just keep that foreground thing in a thread local, and when we resume back in the main thread, we take that out of the thread local and do it. Just make sure it never leaves the thread. That is essentially the rule. And if we were doing this now, I did it like a year ago, we probably use stable ref, which actually just lets you get a stable pointer and then inflate it wherever you want. Be careful, don't inflate it at another thread. But this is where you can kind of get around the rules. You just have to be aware of what you're doing and don't break everything. Then there's this other thing, which is kind of like, I just mentioned it because the native team seems to really like it. Worker dispatch local state. So if you wanted to have a cache, you could have a map that is just managed only touched by one worker ever. And then you call the worker with I want to put this in the cache, I want to get something out of the cache, and you let the worker give you things back and forth. That will perform much better than what I wrote, this library called Stately, which has these collections that are all implemented with atomics, which sounded cool. Performance is not great. So doing something like this will work better. Is it a lot of work just to get a hash map? Yep. So I don't have a better answer right now, but somebody will write a library for that, and it'll all be better. So Multiplatform State. Up until now, we've been talking about native only, but most people in the mobile world are going to be writing shared code between platforms, right? Freeze is native only, so how to handle in common? Well, again, we have this library called Stately, which defined multi-platform implementations of these things. And on native, it would call the method. And on the JVM, it does absolutely nothing. You notice I wrote this at least a year ago because these should definitely be values. And I've become much better at like recognizing what's not, proper Kotlin. Anyway, you can use those. Most people actually, if they need them, just kind of copy paste the implementation from Stately. So that's up to you. If you want to use Stately, here is the thing. It is going to go through a major revision in the next couple of months, largely because of the changes that are coming and a lot of the lessons learned over the last year and a half. Like, we separated collections because they are darn slow, and we're going to try to figure out a different way to handle that. Cool. So just generally, this is nuts, right? I added this morning because I realized when I go talk to people, I'm usually like, hey, you need to understand this or it's never going to work. It's going to crash and burn. Your app's not going to function, blah, blah, blah. And then the reaction is like, that's scary. Maybe we won't do that. It's syntactically similar. It's really not that nuts. I'm just very cautious to explain that you have to know what you're doing. But at the end of the day, it's not that different, right? So most apps I find that are larger apps are doing like a little bit of Kotlin in very sectioned off places, and most of the app is still just native, which is like the Kotlin sort of superpower. The interop is exceptional versus all these other options that are out there, right? So this is more of a sideways diagram. Quite literally did these this morning, so this is sort of my first time seeing them almost. Just make sure that the data that's coming out of your shared code is frozen on iOS. In this case, if you're just doing little parts, you're not doing any threading in the shared code, you're doing it all in your regular native code. You're just pulling state out of there. Just make sure it's frozen. That's about it, and it works perfectly fine. In larger apps, more extensive apps, you might be doing a lot more code in shared code, even crossing the thread barrier. So like in droidcon, none of the native code lives outside of the main thread. It's all in shared code. There are things to be aware of there that are a little more complex. But there are also benefits that come out of that. But fundamentally, at the end of the day, when I was doing a talk about libraries, the whole droidcon app, which is relatively extensive, has 9 expect functions and 2 expect classes. All of that could probably be removed when we update it next month, because there's a lot of libraries that take care of it now. For freeze-related calls, there are 5 freeze calls and 2 ensure never freeze calls. I think we could get rid of most of those freeze calls again with libraries, because a lot of this is hand-rolled stuff. And the ensure never freeze doesn't need to be there. It's like just in case. The point being that as long as you understand the architecture and change things so they're not doing globally immutable state all over the place, there's not a lot different about the app internally. It just feels that way when you're doing it first. It's different, but not really. So next steps. Obviously, there was a bunch of code. I am assuming if you've never seen this, you've retained almost none of that. I have a 2-part blog series called Stranger Threads that goes into detail and gives you examples, essentially what I talked about in the talk, but you can see it live on your computer. And there's a 3rd part that we're going to write. Again, this is trying to incorporate the new stuff that's happening in the past year of what we've learned. There are some JetBrains links. There are READMEs in the JetBrains repo for Kotlin Native. They are complete, sometimes a little dense. And then there's a video from Nikolai, the lead. He's great. It is advanced. So definitely read the blog post and make sure you understand a bit before you watch that, because it might not be that digestible, just saying. So the future, where are we going? So there's this thing called relaxed mode that was committed sometime in the summer as an experimental thing. What is relaxed mode? It lets you have access to shared mutable state, AKA the status quo. If relaxed mode becomes very popular, or it turns into a thing, then all that stuff I just talked about is basically gone and you can forget about it. That sounds like a good thing. I'm not sure that that's a good thing. I call this our own little Brexit. Because if relaxed mode becomes popular, strict mode is just there's no way it's going to be able to stick around. Relaxed mode is a compiler setting. So once you compile something to be relaxed mode, you can't make it strict mode. So that means most new developers will do that out of convenience. Most new libraries will assume relaxed mode. It is gone away. Are there heated discussions about this in the community? You have no idea. But it's okay. I'm not that It's not the hill I'm going to die on. I'm like, I care about adoption. So if relax mode happens and we got to adjust the things that we've already done, that's okay. Personally, I vote remain, but we'll see how it goes. We're all going to make it work. Sorry if anybody here is British. I know that maybe that's not a good joke. I don't know. Just an FYI, relax uses the thing called share, which is another state. There is a function called share on a very special class. It looks like that. You can't call it, but what does it do? It lets you share immutable state, even in strict mode. And I could tell you how to call it, but I'm not. That's why you have to spend time and become a little more experienced. Plus, it'll piss off JetBrains, so I won't tell you how to do that. Multithreaded coroutines, this kind of changes everything. A lot of talk that I have with orgs or individuals that are looking at this, it's like, is this ready? Which isn't a binary question, first of all. But is this, I mean, Kotlin Native. But it kind of depends on you. But also, they seem really stuck on coroutines, like the idea that there's no concurrency without coroutines, or the JetBrains isn't serious about it without coroutines, or it's not ready without coroutines. You know, you need to understand the model, but you can have concurrency without coroutines. Having said that, I think this is a mental blocker that is going to be unblocked very soon. The draft pull request is in there as discussed. I think that what's going to happen after that is there's a lot of like people waiting to do follow-on libraries. People are reluctant to do concurrency libraries because they're all going to get thrown away as soon as coroutines happen. Well, they've happened. So that's going to happen. Architecture stuff's going to happen. Endless blog posts about how this is ready and check out my sample app, blah, blah, blah. That's going to happen starting next year, assuming coroutine stabilizes. So that's a big deal. Today, what can you do? Well, there's this interesting library from Ben at Autodesk. Check out Coroutine Worker. It's pretty cool. You can check out what we did with droidconTO. That's cool. We have like a main thread, suspend coroutine. It lets you do work in the background thread, and it doesn't freeze the main thread, and you use it like this, and none of that matters. Like, wait a few weeks. Wait till Kotlin Comp. I never say wait on Kotlin Multiplatform. Start checking it out, but don't go too deep on the concurrency stuff because I think that there's going to be some discussions and announcements. Unfortunately, I get to talk about the topic even though I'm not involved in the meetings about what's going to happen. So, but they work in the open, so it's not that bad. I will announce this. It's KMP Evaluation Kit. We are talking to orgs. A lot of them are doing like a hack week, and they get a week to try to do something in KMP, and then they find all the conflicting blog posts and all the stuff telling you to use app code and like things that are just not relevant anymore, and it takes until Thursday to compile anything. We are putting together a kit that is just like start here, clone this, do that. Here's a Slack thing. You can ask us questions. We want you compiling by lunchtime on day one so you can really evaluate and play with stuff. The marketing geniuses call this the camp kit. We have a space theme, but it's a camping theme. They're assuring me that they're going to come up with imaging that will merge those things. This will not be ready till mid-December. You have to give your email address if you want to sign up now, and spoiler, even when it's ready, you'll have to give your email address because I have to feed the marketing people something, even if you're not a real lead. So that's all I ask. I promise. Just tell them you're not interested and they'll stop emailing you. That's it. That's me. It's TouchLab. It's Twitter. We are more aggressively now hiring Kotlin Multiplatform, very interested or experienced people. I know there aren't many experienced people. Also, I'm not in the US, and it has to be in the US. I'm just saying that. And we are kind of slow burn looking for a Kotlin multi-platform expert person as a counterpart to me or counterparts over time. So just letting you know. That's it. Questions?